Welcome to True Projects. In this video, we are going to explain about the project that is enhancing phishing detection, a machine learning approach with feature selection and deep learning models. So, before getting into the execution, first let us understand what is the project about. Why cybersecurity is very important? Because in today's world, everything is connected online. So, keeping our digital information safe is very important. Phishing is one of the most common and dangerous online threats. It involves tricking people to steal their sensitive information. So, how this phishing works? Cyber criminals they pretend to be trusted organizations like banks, social media platforms, or government agencies. They try to make you believe that their messages or websites are real. And the main goal of phishing is to get private information such as passwords, bank account details, or the other personal data. And this phishing can happen in many ways through emails, social media messages, instant messaging apps, or fake websites. So, if someone falls for a phishing attack, they can face serious problems like losing money, having their identity stolen, harming their reputation, or even legal issues. So, phishing is a serious cybersecurity threat that affects both the individuals and also organizations, not just a minor annoyance online. And here, even though cybersecurity has improved over time, detecting phishing attacks is still difficult because attackers constantly change their tactics. The digital platforms where phishing occurs are complex, making it harder to identify malicious activity. And the existing systems that we have, that is current phishing detection techniques, often have to compromise between accuracy, that is correctly identifying phishing, and efficiency, that is processing data quickly. When data sets have too many features, especially irrelevant ones, it increases the computational effort and slows down the detection. On the other hand, if important features are missed, the system may fail to detect phishing correctly. To protect users and organizations effectively, it is essential to accurately tell the difference between legitimate and malicious websites, that is, a genuine and phishing websites, while reducing the false positives, that is, wrongly flagging safe sites, and false negatives, that are misactual phishing sites. Efficient and precise phishing detection is critical for safeguarding individuals, organizations, and important digital systems for that is from increasing sophisticated cyber threats. So this project it aims to create an effective way to detect phishing websites using machine learning. Here it works by analyzing a large number of URLs, looking at different characteristics that is features of each website to figure out if it is legitimate or malicious. And then not all features are equally useful, so the system selects the most important ones, which helps for reducing the amount of computation needed while keeping the detection accurate. So, by focusing on the most relevant data and using machine learning, the system can efficiently and also accurately identify phishing websites, helping to protect users from cyber threats. And here, the system uses different machine learning models such as feed forward neural network, FNN, deep neural network, DNN, wide and deep models, and tabnet to see which one works best for detecting phishing websites. After training, the models are tested on new data sets to make sure they are robust, that is, work well under different conditions and generalizable that can handle unseen data. So, by using feature selection to pick the most important characteristics and applying advanced machine learning algorithms, the system becomes more reliable. So, the approach provides a strong framework to help protect users and also organizations from phishing attacks, making cybersecurity defenses more effective. To further improve the performance of this project, here we have used Smotin technique to balance the data set because we have legitimate transactions more than the phishing ones. That is, the genuine URLs are more than the phishing ones. So, to balance this condition, to balance this data set, we have used this Smotin technique. And then, as the model, we have also integrated voting classifier to further improve the performance. So it combines random forest and bagging with decision trees. This approach improves the predictions by using the strengths of multiple machine learning models together. And here, explainable AI models. So to make the system more understandable, explainable AI, XAI techniques like LIME and SHAP are used. So these help to show which features influence the model's decision the most. And additionally, we have developed front-end using Flask. So this Flash-based interface allows users to input URLs and get predictions. This makes the system more interactive and practical for everyday use. So this extension not only improves the prediction accuracy but also makes the system easier to understand and use, enhancing its effectiveness in detecting phishing attacks. And moving on to the implementation, to implement this project, here is the steps that we have followed. So let us understand what did we do. So first, we have imported all the necessary Python libraries and packages to perform data analysis, pre-processing, and model building. Then comes exploring the dataset. So the phishing website dataset is examined to understand the type of data it contains and how it can be used for web phishing detection. So here we have used two types of datasets, that is phishing website dataset and the web page phishing dataset. Then comes pre-processing. So here any missing data is removed to avoid errors in the model training, that is removing null values. And coming to removing duplicates, duplicate entries are deleted to ensure the data set is clean and reliable. Then comes data visualization. So here relationship between features are visualized to understand dependencies. And then some sample data points are displayed to get a sense of data, that is sense of how the data looks like. Then comes feature selection. So here mutual information, chi-square, and permutation, importance of FNN, DNN, tablet, that is tabnet, and wide deep models are used for selecting the most important features. After this, the top 20 features are ranked based on their importance to improve the model efficiency and accuracy. In the next step, the input features are assigned to variable X and the target output column is assigned to variable Y. Then the data set is split into train and test sets, where training set is used to train the model and testing is used to evaluate. Then we will be initiating all the machine learning models and then we will be training for detecting whether the URL is a phishing website or a not phishing website. That will be evaluated through confusion matrix, accuracy, precision, recall, and FN scores, and that performance will be visually represented through graphs. And we will be saving the best performing model. After that, techniques like climb and sharp are used to explain how each features are showing the model's predictions. So how each feature it affects the model's predictions. Coming to the front end part. So here a user interface is developed using Flask framework, including registration and login with SQLite as a database for storing user data. And user he inputs URLs as the links that will be pre-processed at the backend. It will be fed to the train model. Train model will be predicting whether that link is a phishing link or a genuine link. And these are the algorithms used in this project. And to implement this project, we need hardware and software requirements. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software requirements are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview. Now let's execute. To execute, open the code folder that contains source code files. These are the source code files of this project. In this, we have the dataset 1. So this is the dataset full. It's opening, just wait for a while. Until this opens, let's check with the other files, get back. So in this model folder, we have the algorithm information that will be loaded into the project code during runtime. And here the dataset is open. So these are multiple characteristics. So these are the multiple attributes based on which we will be detecting whether the URL is phishing or not. This is the target column that we will be predicting. So here multiple, so we have n number of features, so many features. So that is why we are using feature selection technique to select the important features. Close this. And this is the static folder. Inside this folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And the next folder is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And we have test cases inside which we have multiple URLs that we will be using in the front end for predicting. And this is the web page phishing detection. So here we have other data set. get back. And this is the app.py file. So this .py file, it contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And these are the two notebook files. So it's a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. This is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. So copy it. Now open Anaconda prompt. It is open. Give the command cd, give the space, paste the copied path, and now click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. So after running the app.py file, Flask Framework will host the application locally at the default address, which is the local host and the port unless configured differently. So just wait for a while. Here we got the link. So this is the address where application has been hosted. This is the local host and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So this is the web page of the project. Now click on click on get started and enter all the registration details if you are not registered. I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password. Click on sign in. We have signed in successfully and we are redirected to prediction page of this project. So this is the prediction page of the project. So here you can click on get protected. You will be redirected to a place where you're supposed to give the phishing link or the legitimate link. So let's open the testing cases. Open the sample file. So here we have segregated some of the phishing URLs and safe URLs. So let's try giving the URLs and see whether the application will correctly predict it or not. So let's copy the first URL, get back to the application, paste it, and click on detect. So here we got the prediction that it is phishing website. So here phishing website is detected. So please be careful and click on back to home. Select the other URL, copy it, get back, paste the URL, click on detect. So here it is extracting, click on back to home because here we got the prediction as phishing website. Let's check with this one. Copy it, click on back to home, click on get protected, give the link, click on detect. It is extracting, analyzing, and then it will predict. This process will happen for all the links that we give. Here also we got that it is a phishing website. Now let's check with the genuine websites and see whether the application will predict it correctly or not. So copy this, copy it, open, paste it, and click on detect. It is extracting. So here it is non-phishing websites. The website is safe, but be careful. So it is telling us be careful. And we can click continue to website. So let's click on that. Here, if you see, it is redirecting to YouTube. Let's close this. Close it. And now click on back to home. Copy any other URL. So let's try with the WhatsApp web. Get back and click on detect. So here also we got the prediction that it is not a phishing website. Click on continue to website. So here it is redirecting to WhatsApp web. Close it. Now let's try with the other links. Now let's try with this one. Get back, Click on get protected, paste it, click on detect. So here also we got that it is not a phishing website. Let's check with the other one. Let's check with this last one. Paste the link here. So here we got the prediction that it is a safe website. If you click on that, you can see the website link. So close it. Now let's check with the graph. So click on about. Here we have multiple visualizations. So this is the sample outcome where 0 refers to not phishing and 1 refers to phishing. And on y-axis we have count of each target. Close it. And here we have confusion matrix. This is the confusion matrix of the voting classifier. And here we have ROC curve. And this is precision recall curve graph. And here we have accuracy comparison graph. Here on x-axis we have all the models that we have trained, and on y-axis we have accuracy. Similarly, we have precision, recall, and FN score. And here we have SHA plot, which shows the feature importance in predicting that variable. So that's all. We're done with the graphs. Now click on sign out. So in this way, just by giving URL to the application will be predicting whether that URL is genuine or fake. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.